Is the music just quiet? There it goes. Yeah. Yeah, if you bring snacks, you have to bring enough to share with the class. Hey, Joseph. Which is the most twisted logic ever. Okay. I want to solve Schrodinger's equation. I was trying this off stream the other day. It was not working. No clue what Schrodinger's equation means. But I want to solve it. Hey, 750. How's it going? You love cat girls? Cat girls are pretty lovable. I can't blame you. Taking a bunch of screenshots right now of things I'm going to need for this problem. Where is... Okay, here it is. I don't know why I was making that noise. Success is a sure thing. It's kind of a weird fortune. Usually they give you advice on how to be successful. They don't just tell you that you're doing great. Keep doing what you're doing. Dawn does some scrolling. Yeah, this is just a scrolling through a book stream. It's not even reading, it's just scrolling. I know I'm not doing great. That's real. Anime traumatized me. Okay, so we're gonna take the Fourier transform in X. For the part B, we're gonna do the Laplace transform in T. So this is a second derivative, so it's gonna be a negative k squared. Oop. U hat, capital U hat. I guess it's k. Oh, is that what got me messed up? Did I make that an X when I was doing this off stream? Wait, no, it's no. It's just a U hat. Okay, and so we can rearrange this equation to look like minus ik squared. Laplace transform. What I have in the upper right here is Fourier. The Laplace transform is very similar. This is the definition right here. I think the main difference is that S is a complex number in this exponent, and in Fourier, it's a real number. Well, they use K there, but I think that's the biggest difference. Laplace transforms, for some reason, they're also only for 0 to infinity. Or like for functions that are defined on 0 to infinity. Or at least that's what this book is presenting it. I don't know why. What is a Green's function? Well, I can quote the book at you. I don't fully understand it for myself. A Green's function solves a PDE Actually, okay, so what they say with delta function inhomogeneity, but the way they used it was a delta function initial condition or boundary condition, I should say, which I don't understand that piece of it. This is where they first used the term Green's function. So yeah, with delta function inhomogeneity. Hey, Yanis. Oh no, integrals? Oh, it's even worse. This is PDEs. But we doing well. You know, I should just look up Green's function. But the advantage of Green's function is you can use them to construct solutions with any other boundary condition, I think. Do I believe in going directly solving problems before learning theory? I believe getting a surface level understanding of the theory, solving problems, deep understanding of theory. That's the order that works for me personally. I didn't truly understand the theory of calculus until I grinded through a bunch of derivative and integral problems. Okay, so Green's function does... So I really don't understand the book's explanation. Because the way they got Green's function was from a homogeneous equation. So I don't know what kind of crack they're smoking there. Solution to the initial value problem, Ly equals f, is the convolution of Green's function and f. Hey, Skirtle. LG? No, it's not the Korean brand. L is just a general linear differential operator. So it just means some combination of derivatives of Green's function. So it's just a generalized way of saying like some differential equation. It could be like Laplace's equation. Like L here would be second derivative in x plus second derivative in y. But it could, you know, you could have a different L for like the heat equation and stuff like that. Through the superposition principle, given a linear ordinary differential equation, Ly equals f, one can surf to solve Lg equals delta s for each s. Since the source is a sum of delta functions, the solution is a sum of Green's functions as well. Okay, so that's what I kind of had in my head, which is you could theoretically construct any function you want out of a whole bunch of delta functions for every point of the function. That just seemed kind of impractical, but you could do it, I guess, theoretically. Dora the Explorer, it has been a minute. How have you been? What do you think of the life on Mars thing? I still haven't, like, learned any details about that. In terms of, like, some vector space? I bet so, Destin. I don't know the theory of that, but this does look a hell of a lot like a matrix equation. For some reason, I found the term green function of a random walk on ZD, and I am confused. Ooh. I think I remember seeing some 3 Blue 1 Brown or Veritasium video on a connection between random walks and differential equations. I want to say there is one. Um, oh, it was with yeah, I remember now. It was a Veritasium video. That had to do with is it called the equation for the stock market, the something Scholes equation, Black-Scholes equation. This has a connection with random walks. Because like the way that stock markets, for the sake of math, you assume that stock markets are basically random to produce a graph like this. I don't know the exact connection, but there is a way to connect those things. So that might be what they're talking about, cold gold. But I guess the simple answer to what is a Green's function is that it solves a differential equation that's inhomogeneous if it's equal to the direct delta function. I think that's the quick answer. Let's catch up with chat. All good. Kind of pause my thesis for a bit to work over summer and catch up on old exams. Back on the grind now. Nice, nice. Oh my god, Destin, it was on my mind to watch it. I keep kicking myself to watch it. I really want to. I keep forgetting. Fizbuzz gave me a video that I have to watch too. But, you know, okay. Let me dig through my YouTube history. I'm going to open up a tab for the video that Fizbuzz told me to watch, and I'll open up a tab for the one that for the interview that you linked. Because I do want to watch this, and I will watch them tonight, sometime after the stream. Search watch history. Strogats. List has no video. Bruh. July? It wasn't in July. Watch it on stream. Honestly, it was a lot of fun to watch videos on stream last night. Why isn't it? Was I logged into my other YouTube account? Is that the issue here? Okay, I'm gonna find the Shurats interview later. So I really can't find it now. Okay, yeah. Oh, thank you. Fault tolerant control for a slider robot. Yeah, Dora does space stuff. I don't know if I haven't seen you stream, but again, the time zones make it hard. But Dora at least has streamed about space. So if you have any like space questions, hit up Dora. This is one that Fizzbuzz linked to me last night. It's a physics one. Is there a linear algebra definition of green function reference or something? Yeah, no pressure, Dora. Eigenvalue expansions. Oh, That is, wait, that's a proper use of, so Automa just held a comment for using a certain word, but I think this is actually an appropriate use of that word. Okay, yeah. Well, that's annoying. I'm gonna hit allow. Uh, because that is a real thing in math. That's not being used in a derogatory way. This actually interests me because I heard that Fourier theory can also be constructed with algebra. Interesting. Topological vector space with its dual. So that's not something that I know anything about, but I bet that there is some higher, or not so higher, but like different way of representing it. It might be like somewhere inside here even. Huh. You can have a table of Green's functions. Is this for the linear differential operator? Hmm. See, I wouldn't know enough about this to really say much that's interesting, but I bet there is something here to dig into. Those look like linear algebra words. Which is an integral kernel representing the inverse operator L inverse. That sounds like a fancy way of saying this solves a differential equation, I think. But this might be the type of explanation that you're looking for. That sounds way better to yeah. And it doesn't sound better to my ears, but I thought it might sound better to yours. There might be distributions for keywords. Okay. There's something about being able to construct a Fourier transform in locally compact groups or something. Yeah, I've at least been learning about Fourier transforms with LP spaces. So this book is it's very applied, so it's really trying hard to avoid talking about this too much. But you can talk about Fourier transforms apparently in L1 and or in L2, and this is the definition of L2. And for the sake of simplicity, this book only looks at L1 intersect L2. But if you do some more fancy measure theory, functional analysis stuff, you probably learn a lot more about this. Next thing is an L2, the Fourier transform is an isometry. I don't know what that means, but that does sound nice. There's a lot of the words like that. There's so many of them. Like I'm thinking of like isomorphism, diffeomorphism, homomorphism, or whatever. Like all those types of words. I'm not familiar with. Isomorphism and preserves distance. Okay. Yeah, so this is where like I become completely ignorant of math because I intentionally avoided any type of theoretical class when I was like doing my degree. Even though this is pretty advanced stuff. It's the best part. I do regret avoiding them to the degree that I did, but at my heart, I prefer applied math. So, I definitely have been more interested in learning about measure theory after reading this, though. Isometry just means dihedral group minus the weird flipping. Really? Oh, like that's what it's isomorphic to? Okay. I don't like truly understand that, but I can believe it. Okay, so what I was working on was this PD here for Schrodinger's free equation. You don't have to pay anything for this equation. It's free. Hey JC, hope you're doing well. That's not what I meant. Fourier transforms goes from L2 to L2 and is an isometry. Okay. Fair enough. Or maybe Desson meant that in a different sense. I don't know. Some functions by left translation? Yeah, I have no clue. Hey, mouse. Some constant with respect to t, so it could be a function of k. Feel free to shoot, I guess send your questions to me. Oh, what, you can't solve Schrodinger's equation, mouse? Come on, no. I can't solve it either, so... Drops the cheese. Bites Desson. You can't solve any PDs. That does make me feel a little bit better. Because I can't really even begin to understand the type of math that you like, Desson. So I feel better that I just have my thing that you might not understand. If you get in a fight, your move is to bite? I feel like that's not a very practical fighting method. I don't know. I think I've been a little bit sketchy on this. I mean, I haven't truly been in a fight, so I guess I wouldn't know. 20, holy shit, mouse. I was been a little bit sketchy on this, but I'm pretty sure we can take the Fourier transform of our boundary condition too. Hardlocked, thank you so much for the tier 2 sub. Happy Pythagorean Theorem Day +1 to a squared. Oh yeah, I heard that. Yesterday was a Pythagorean triple. Maddie Eng, oh my gosh, it's been a minute. Hope you've been well. Hardlocked, I hope that you're doing well. But yeah, yesterday, at least if you're American, you wrote yesterday's date like this. And this is it looks like the Pythagorean triple 3 squared plus 4 squared equals 5 squared. Hey Sage. I hope so too, considering it's a desktop computer plugged into the wall. That is unacceptable, F. Day, month, year. That is just better, FA. I do agree. Let me look at what... I'm kind of curious to see what Yanis is linking there. So it just looks like a big word. Or big series of words. Who's up after a long time? See the Schrödinger equation on the screen? Nice. I tried to solve it off stream a day or two ago and I couldn't do it. So I'm hoping to get redemption today on stream. Jesu, hello. It has been a while. I did hear from Syntax that I believe the semester started, so I hope that's going well for you. Coming for 2 Pi days every year. Oh yeah, he's back from the grocery store. I am gold. Yeah. I meant to go to the grocery store much earlier, but I was so like invested in the problem that Zach was doing that I couldn't stop. I feel like I always need to be better about shouting people out when they pop in chat. Actual Education / Dr. Gold is a good friend. Check him out. Want to reckon another European, right? JC, I don't know if you're saying what the hell to what's on screen right here or what I was doing before. I don't know. I told my mom about you. She's going to call you today at 4:23. You know, I'm used to having a lot of moms calling me. I'm pretty popular with moms. On the screen here, I have no clue. Pointriagan? I don't... How the fuck do you pronounce that? Duality is a duality between locally compact abelian groups that allows generalizing Fourier transform to all such groups. Yeah, I don't know what this is. There's a pretty picture though. The opposite values will do that? They will, yeah. Sometimes in a subcategory of groups. Fair. Just gonna hug my panda. I don't like this. Supposed to start in Finland, but I'm still in the UK. Oh, right. Paper has been accepted as in getting published after I sign off on the proofs? Hell yeah. So wait, is that different from your, like, dissertation? Like a different paper? Related to Yoneda? I wouldn't know. Okay, I think... So the thing I was working on was this Schrödinger's equation. I'm gonna have to put it down for now because I think Mouse posted his questions. But we'll come back to this. Yeah, we got 2 coming in hot for Mouse. Ooh, got a contour integral. Oh, that was my friend Skirtle. She typed something in chat earlier. What's the other one? I guess we'll see if she replies to my @. Lucas, I got a 72% on my math test, and the teacher decided for no reason to change the amount of points a test was on from 34 to 18. So wait, did your score get scaled then, or if you're mad about it, I assume it wasn't in your favor. I'm not sure that's a bad thing. I don't know. Eldritch, hey, do you change your name again? I see a VT now. It's the paper in the best journal in my field. But and yes, not your thesis. Well, hey, dude, you published like 2 different papers before your thesis. Fair enough. You solve contour integrals. How much do you charge for tutoring? It's free if you ask me on stream. Math, my math. I'll try. I'll be evolving. Nice, nice. Chill off tomorrow's your chemistry exam. Good luck. Test on more points is more. Oh, like it's worth more. Okay, yeah, that's fair. I got my model. I'll be spreading misinformation. Oh no. Good luck, chill. Okay, I think neither of these are simple questions here. Which one do we want to start with? Maybe let's start with the residue question. Yeah, so Lucas, and so when you first learn about integration, it's only in a 2-dimensional space with 1 variable. When you get to multivariable calculus, the idea of an integral kind of changes. And this is called a path-fit integral, as Jasu says. It's a little bit hard to describe, but it's an integral in 3 dimensions, basically. One of the ways you can integrate in 3 dimensions, at least. There's multiple ways. I don't usually save them, no. Okay, so let's start with residue one. I'm assuming it's going to be more straightforward. I don't know. So we have to calculate the residue of the singularity, the isolated singularity of this function. The singularity is at 0. It's an essential singularity. So remember how to calculate residues. Where do we do this? This guy, Zane. I remember your name. You switched me to get a grade 8 in maths. Now I'm doing maths 8. Well, hey, hell yeah, Zane. Congratulations. Oh, are they looking for the Discord link? It might be DC for the abbreviation. Complete my first year, got a B grade, now my second year, final year. Nice, Zane. Good luck with closing it out. Published my 5K page manuscripts posthumously. Is that how people found the formula for the area of hyperbola, for example? That I think you can do with just... No, the area of hyperbola is tricky. That's called an elliptic integral. It's a normal integral as you first learn about, but they're very difficult to solve. I try to remember people as best I can, Lucas. I feel bad if I don't. That's the book there. I think we might need to go to the power series. That's my gut feeling here. Sounds good, Zane. Well, yeah, let's just see what the power series for this looks like. So the power series for E, just regular old E, let's not worry about 1 to the Z yet, is n equals 0 to infinity, Z to the N over N factorial, right? So if we have 1 over Z, we just put a 1 over Z in here. And then we do have a z squared out front. So z squared e to the 1 over z equals 0 to infinity. 1 over n factorial z to the n minus 2. Because what I did here is I took this and I multiplied, I brought the z squared inside, and I canceled the exponent down there. And so I think we probably want to expand this out now. Sounds good, Desmond. So the first term is 1 over z to the... Wait, it's 1 over z to the minus 2? Okay. Next term is 1 over z to the minus 1. Next one is 1 over 2 factorial. The next one is 1 over 3 factorial z. 1 over 4 factorial z squared plus dot dot dot. Okay. Oh my god, Dr. Cook just drops a YouTube link after not hearing from you for like at least a month. Let's see. Is it gonna be about waffle stomping? Volume warning, I don't know how loud this will be. Oh. That is the typical saw dude. This is a vine? That makes sense. So I think that's stupid. Hey, Cook. Hope you're doing well. This was popular years ago? Fair enough. Popeye and drop a DOI. Oh, I paused the music. Let me bring it back. How's school? It's not starting until next week. This is my last week as a free person. Got orientation on Monday, then class on Wednesday. Is this 19th grade? This is my studio apartment that is close to campus, but not on campus. Wait, what would grad school be? 12th grade is senior year of high school. I only did 3 more years of college, but normally it's 4 years. That'll bump me up to 16th grade. I guess first year of master's would be 17th grade. How do we... What's the poll? So I thought we'd be able to make this look like a poll. Maybe singular... I mean, oh, I guess it's an essential singularity. That's kind of not a thing with essential singularities, right? Cook, I have actually been on a whole quest to get new shoes. Chill, Luffy, there really is no secret. You just have to practice a lot, unfortunately. So, I have wide feet, and it makes it very difficult to find shoes that fit. I went to a Nordstrom rack. I could not find a single pair of shoes that came in a wide size. I did some research. I found out that there's actually 2 stores in Seattle that are called Wide Shoes Only, and I was like, oh my god, that sounds like heaven. I'm gonna go there. When I walk in there, one of the first things they tell me is they only carry shoes in extra wide. I just need regular wide. So it's like I'm just fucked because I'm in the middle. No shoe stores carry shoes for me. And so what I just did yesterday was go online and I ordered some New Balance shoes. online, and I'm just hoping I got the size right. But yeah, I've been on a whole quest for new shoes. Hey, Elkander, welcome in. Thanks for providing the translation. That's the cover there. Destin, I take notes and I take handwritten notes specifically. For the class that this book will be attached to, I guess I'm gonna be prepared considering I've spent like 4 months studying this, but the boomer dad mowing the lawn, white New Balances. I got black New Balances at least. Hi in Russia, nice. Welcome in. But yeah, honestly, like it just the choices are so limited. Like New Balance is one of the few brands that are actually good about carrying shoes in wide. Yeah, so I think I had really good timing. So I just went to Target yesterday, and they had 1 second. They had a bunch of the like the really big notebooks on clearance. So like it's like one of the thick boy notebooks. And this one was $4, the other one was $2. So it's kind of a steal. But yeah, no, I much prefer handwritten notes. Allbirds? Okay, I haven't heard of them. How did nobody clock? Oh, what are those? I get it. I thought that was a really stupid joke, but I did hear about that one. You met a ginger today. Nice, Mouse. I'm still trying to figure out how you get the residue around an essential singularity. I don't know how to do this quite yet. Okay, I guess this is what we want. Oh, duh! The residue is the C-1 term. That's all you have to do. You get the Laurent expansion. And it's the coefficient. You have to multiply this in, and then you go for what has the power of 1, which will be this term here. Okay, this really is not that bad. So I forgot the actual definition of residue. You look at the 1 over z term, and you take the coefficient. That's your residue. So the residue of this is 1 over 3 factorial. Which is 1 over 6. Okay. That took me way too long. Helps not to your notes so there is no residue. Thank you, Jasu. Okay. Nice. So, that was a quick one. I was just stupid. This one looks a little bit mean. Right, Cook. Yeah. That's the reason why. And so since we have cosine of sine, I think we need to go like cosine of z is oh wait. Cauchy. Oh no. Cauchy's integral formula. We don't need to actually integrate this. Thank God. Oh, ooh, yeah. Yeah, yes. 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 Okay. Oh, thank God. Okay. So... So I always get a little bit mixed up, because we have Z here, but this integral's in zeta. So I'm actually gonna, just to make it match the way the book presents the formula, I'm gonna translate this to be zeta for our integration variable. And there's an invisible -0 here. So I'm gonna take the 2πi, multiply it to the other side. 2πi times now this thing with 0 plugged in. Cosine of sine of 0. 2πi, sine of 0 is 0. Cosine of 0 is 1. So just 2πi. Nice. To lower my volume. So you sounded weird for my family. Oh, yes, times 3 sounded weird. Oh, yeah, if you're listening to me through speakers, that's potentially dangerous business. I was excited because I thought it was going to be something super complicated. Dr. Cook wanted to series expand the sine, then series expand the cosine. Oh, there might be something there too, but I think this is the intended way. Make it f of mouse. Yeah, I could have done that. Elkander, I'm sorry, I can't understand that. I don't speak Russian. Oh, okay. So yeah, and I'll try and you told me that I speak a little bit too quick, so I'll try and slow down. So here it's fulfilled because f of zeta is cosine of sine of z. Or I guess zeta. And these are just exponentials, so they have no singularities. Maybe at infinity, but I don't know how that works. I don't remember how that works. But whether it is infinity or not, we're not enclosing that, so that's okay. It doesn't matter. So this function is analytic on the unit circle and inside. So that's why on and interior to the unit circle. Yeah, that's fair, Destin, if you're being proper. IVK, I hope not. My Shimmer bot keeps not working, and it's really annoying. Oh, you mean not? Because I would always pin this message, and for the message it isn't getting automatically put in chat like it used to. And I don't know why. Death penalty for lack of rigor. Okay, so those are Mouse's questions. Thank you for the questions, Mouse. Uh, Destin has posted 2 problems, it looks like. Hey, Codify, welcome in. It's a great name. Thank you for the follow 3 hours ago. How's it going? Do whichever I prefer? Alright. Let's look at them both and see what appeals. Let big F of Z equal that series. Find its power series. Okay, yeah, fair. And find its radius of convergence. I can see an idea for that one. Or we can evaluate the integral from 0 to pi tangent of t plus ai dt for a not equal to 0. I don't immediately have an idea there. Become a math streamer yourself? Oh, hell yeah. Have you already streamed? I'm following you right now. My thought would be, I don't know what my thought is. I have an idea for the top one, so let's start with that one. Am I getting famous? So you remember us when you're the new Grant Sanderson? I think no, I'm not getting famous. Yes, I will remember you. But yeah, Codify, if you're not aware, you probably are, but there's a whole little niche of math streamers here on Twitch. And so that's a whole list that I like recommend the most. But yeah, there's even more math streamers than just that too. Never done a real stream yet. Did a practice one last night. Working kinks, I'm sure. Working out several kinks. Yeah, it's a never-ending process. Yeah, if you want, feel free to like say what your background is. What like the theme of your stream is. What type of math that you like. I always want more people to stream math. So say stats and instant pen. No, we like stats here. That's when I told her, listen here, put in pop, homie daddy, don't joke like that. I feel ya, Tyler. 14 viewers for a math stream is like 10k for an ASMR stream. Sounds good, IPK, thank you. Hey Slim, math on Wednesday, yep. An ASMR math stream. I feel like that there will be people who just like call a stream like this ASMR, like just someone like studying math. I'm probably a little bit too loud and annoying, but I want to do a +1 -1 thing here. A hot tub math streamer? Yeah. Undergrad at Louisiana State University? Hell yeah. Looking to include a variety of graduate topics I'm studying right now. That's awesome. Stats equals man. This be a quant, it was fun? Nice. So I want to do a 1 minus 1 minus z to the n. I think that... Oh, this might not be a good idea. Because aren't I making a piece of this divergent? I don't know if I like this idea. Zach, slash e2ai pi. Thank you so much for the raid. I hope the rest of your stream went well. And was here on mine. Check out Zach. He's awesome. Obi, hey. JC, welcome back. Today will include homotopy type theory. Nice. Hey, $10. So yeah, oh wait, my thoughts on quant? It probably is, it is a good career choice. I don't know much about being a quant, to be honest. Most smart would you rather ever? No, I did not see that. Felix, hey, hope you're doing well. Standard Taylor theorem? I probably have seen that, I just don't remember it. Dr. Cook saying take derivatives, evaluate at z equals 0. Really? Oh wait, I thought I was just gonna rearrange this to get this form. I wasn't gonna actually... I guess you could take derivatives. So yeah, we've been working on this problem from Dessen. Dessen also asked this question down here that I don't have an idea for quite yet. But this one at least felt like I could maybe work something out. Yeah, that might be the play, Cook. Just go to the definition. Would you rather be the smartest person at Yale or the dumbest person at Princeton? I don't know enough about either of those schools to really get that, I guess, but smartest person at Yale doesn't seem like anything to sneeze at. But yeah, we also just been talking to Codify, who's apparently just started to stream math. So I haven't watched any of their streams yet, but I always like to encourage people to stream math. So if anyone is like me, who doesn't know Codify, you should check them out. I was the smartest person at Princeton. Okay, I think my idea here is bad. And it should feel bad. The flyest dude at UCSB? That's pretty fly. That's true, Lucas, yeah. You know the flyest dude at UCSB, ooh. So I guess let's try Dr. Cook's idea of taking derivatives. Let's expand this out though. Wait. Doesn't this series diverge? The limit to infinity is -1. It's not 0. If you multiply z to the n by 1 minus 1 over z to the n, you have a power series. Oh, Cook, that's so much smarter. I was going to expand just to get the first few terms. But that's not smart, right? I don't see that idea, Mouse. I don't know. But I mean, it's a quotient rule here. King of the Brocian. Uh, quotient rule. Low, D high, minus high, D low. This is gonna get really complicated though, Cook, isn't it? Also, do we start from n equals 2 now? The first term is not constant, so I think we still start at 1. I don't know. The coefficients 1, 2, 3, 4, 5, 6. Maybe? Long life is in store for you. A visit to a fresh place will bring strange work. That is a weird fortune. Oh yeah, for this one that's probably a good idea to use product rule. Yeah, it depends on the integral, Sarthak. The quotient rule is scuffed AF fam, no cap. Oh my god, for ABBA, Dancing Queen doesn't. Going to Helsinki, set up collaboration on weird projects. There you go, Jasu. It knows. Oh my god, I didn't do the derivative right. Bruh. Dude, like, chat's popping. It's hard to stream when, like... people are active. I love to see it. It's a good problem to have. But this feels like challenge mode right now. Sarthak, you can type it there in chat. I think it would be the easiest thing. And so let's not simplify this because we're plugging in 0 anyway. Is this not just all 0? Oh wait, we probably have a constant term, right? Do you tell your fortune cookie I didn't like LLMs? Oh, I guess I didn't. I didn't understand Poison Mouse's idea. I read it, but I just... It's hard to, like... It's hard to follow multiple people's ideas at the same time here. Oh, integration B. I'm sorry, Sarthak. I cannot do integration B either. Always cite your sources. Why take the derivative? I was following with Dr. Cook's idea of just doing the definition of Taylor series. That's not a bad fortune. AK should be K times K factorial, codify as calling it. Do we know the power series for 1 over 1 minus z to the n? I don't... Am I stupid for not recognizing this? Like, some of that. I mean... Or like, because, well, Mouse's idea was to look at just this piece of the function. And then multiply the z to the n and after. But like... Just got smashed up because we ain't cooking the question. If I understood correctly, Mouse's idea was to replace the summoned z to the n over 1 minus z to the n by the summation k equals 1 to infinity z to the nk. A double sum. So... Well... This is a geometric... No, I don't understand this, but manipulation. I don't see how we get a double sum with this. It does feel like there should be a simple way of doing this. Like, we shouldn't have to do derivatives. Okay, Mouse just wrote out. Oh! Okay. That makes more sense. Yeah, I can see that. Yeah, geometric. Sum of divisors of k factorial. Ooh. Okay, so I see what's happening now. So we're saying it's z to the n times 1 over 1 minus z to the n. This is a over 1 minus r. R is z to the n. The power of n was throwing me off. But just treat the entire thing as r. And that's how you get that. Okay. That's a thing. It's definitely not nothing. Where can we go from here, though? This feels like we need a theorem now to deal with this double sum. Maybe not. I don't know. Do we just try looking at the actual terms of this now? So now this is only even terms here, right? Okay, I kind of this does seem like it's getting to what something like Codify was talking about. Because this is going to be multiples of 3. Okay. I'll stop after this. Okay. Well, we can definitely get coefficients for the first few powers. Like, there's only a single z to the 1. 1z cubed, 1z cubed, and that's all. So 2z cubed. Oh wait, I should probably do z squared. 1z squared. Did I skip over a power of z here? I must have. Yeah. So 1z squared, 2z squared. Z cubed, and that's all? Oh no, that's not good. Yeah, we would need the sum of divisors here, right? Or this is... Okay, so it's z to the 4, z to the 4, z to the 4. Phone open, journal ++. Yeah. Just confirm for z to the 5th. Z to the 5th. We're only getting 2z. Wow, that's... I mean, isn't it just like sigma of n is a number of divisors? Like, we can just give an answer in terms of that, right? Yeah. Dessen in chat. I don't think there's another way of doing this. I think that's the answer? Question mark? Oh, we haven't found the radius. That's gonna be tricky. We're gonna need to use some properties. I think we might be able to use some properties of the divisor function. I think it has some nice ones. Actually, we can just delete that. We don't need that. So I think Cook's way of just bashing it with the definition would have gotten us here too, but a little bit slower. NASA's calling it as 1? Sigma is always positive. So we need to know what the properties are to deal with this. I guess I would settle for like the asymptotic. Like, right. I was thinking that once we used your step here, we are restricted that z to the n is less than 1, which means z is less than 1. But I don't, like, we could theoretically get a further restriction somewhere else, right? Like, isn't it still important to check this? Wait, is this the exact thing that we have? Like, this one right here looks really similar to our problem. Hey, Naman. Okay, so I do think we can justify a radius of 1. Uh... What? What is this? Does it just asymptotically approach log 2? That seems weird. The magic number? The Euler macaroni constant? Wait, when was Romano's-on alive? 97? Ah! No, okay. I don't know how he's credited in 1997. That's a different Romano. Oh my god, imagine trying to fill those shoes. Hey, Tharv. Macaroni. Oh, at LN2. Yeah. There probably is some type of justification somewhere in here that sigma of k plus 1 over sigma k asymptotically approaches 1. I don't know how to read this. I only vaguely know what little o and big O does. But I would assume you have to make an asymptotic argument there. I don't know. Uh, I'm saying that this limit is an exercise for the viewer. It's an exercise for the Twitch chatter. That's kind of interesting that you can construct a series that has the divisor function as its coefficient. So Destin also posted this one here. Uh, I'm in Pacific, that time zone. I'm in Washington State. Every unit root is a singularity of this function. Riemann, inverted V shape on the graph. What would be tangent at that sharp point? Oh yeah, so those are called, they might be called cusps. I don't remember if that's what you actually call them, but like if you have like any type of corner on a graph like that, there is no yeah. Like if you ever have a sharp point like that, there is no derivative defined at that point. That there is no tangent line, because you could draw infinitely many lines that all like are tangent to it in some way. You can talk about a one-sided limit, like you can get the tangent coming just from the left or just from the right, but overall it doesn't exist. Exactly, yeah, that's a really good way of putting it. Or like no like unique one, I guess, yeah. So we do have a sum identity for tangent, right? I assume this is just like a for fun question that doesn't ask, so I'm not like super worried if we can't answer it. We do have that bad boy. Hey, Ninja. So tangent normally has singularities at pi over 2 minus pi over 2. Hey, Ivan. Oh, yeah, you know what? It might be good to go to the complex definition of tangent. I just need to remember it. Complex definition of tangent. So that's worth looking at. We do need to figure out if this integral is improper, by the way, with the bounds. Ivan is a physics and philosophy streamer. Very nice experience. Just listening to that stream. Check him out. Naman says, so can we say the nature of the graph needs to stay the same to define a tangent? It's okay if the slope is constant, Naman. It just needs to not do anything crazy. Like, it shouldn't jump, and it shouldn't have a sharp corner. Other than that, you can pretty much always find a tangent. Integration by parts, we can talk about that. An improper integral, a simpler example of one is the integral from -1 to 1 of 1 over x. This is called improper because the graph of 1 over x looks like this. There's a vertical asymptote at 0. And so what does it mean? Like, and this interval includes 0. So how the hell do you deal with that? That's why it's improper. There's a way to deal with it, but you need to like state it. Najaf, I'm not sure how to do that question. Naman, a constant slope just means it's a line. So any linear function has a constant slope. And so the like, yeah, it's the same playlist as last time. This is Figuratives by Moderns. No worries. The derivative is the slope of the tangent line, yeah. Okay, so this one was just kind of a for fun question. Art did ask about integration by parts. So I'll keep this one in mind, but I think I want to talk about integration by parts. So I'm just going to say integration by parts. Use it when you have two functions multiplied together. And you're trying to integrate that. So honestly, I'm just going to tell you how to do it because that was the most helpful thing for me when I was learning this for the first time. Basically, you choose. The way I was taught is you use U and V. Some people use F and G. I always set up a little like 2x2 grid where one thing is U, one thing is dV. So I'm just going to say U is f of x here. dV, you know, this is bad. I should use an actual example. Let's use a real example. I know it's the right way to do OB. It didn't help me when I learned it for the first time. That's why I'm not saying it. You know how to do it with ln, you get confused. Oh. Would it help you to see it for like x, ln x then? Wait, is that a... Yeah, that is a good example. You think a not equal to 0 solves the infinity problem? Maybe. I was thinking if t is like pi over 2 minus ai. I'm not sure. Yes. Okay. So I'll do this one. Maybe intershape parts. I'm not rusty. Yeah, it's basically the reverse of the product rule for derivatives. Or like it undoes the product rule. And so with integration by parts, I always think about the one that kind of like I call it degrades as you take the derivative of it. ln x is a really annoying function to integrate with usually, but its derivative is amazing because it's 1 over x. So I'm going to choose u to be ln x and dv to be x dx. And so we're going to take derivative of u, 1 over x dx, and we're going to integrate dv to be 1/2 x squared. Then every time I have to draw this little uv minus v du. That's how I remember the formula. I draw that thing. I don't know why it works for me, but I've shown it once and it's stuck in my head ever since. So uv is 1/2 x squared ln x minus integral v du. 1/2 x squared times 1 over x dx. And now this integral is way easier. Minus 1/2 integral of x dx. So we get 1/2 x squared ln x minus 1/4 x squared plus c. And so there's actually like an acronym for integration by parts. LIATE, liate. It helps you choose what to take the derivative of. If you have an integral that you think you need to use integration by parts for, you often want to take the derivative of the log. That's just a pattern that's good to know. After that, you want to do inverse trig. After that, algebraic functions, which are polynomials. Then trig, then exponentials. And so that's just a nice like rule of thumb for how to choose what to take the derivative of. Don flexing his calc skills. This is my comfort zone for things to like tutor. Complex analysis, I'm like feeling my way blindly around a dark room, but Calc 1, Calc 2 stuff, I love that. And if you know to figure out a way if a differential equation is integrable, I think you just have to play with it, Mouse. I don't know if there's like a systematic way. For Bennius theorem? Oh, for Mouse's question? Maybe. Don't memorize the stuff, just practice. Yeah, it is better to learn it intuitively. I find a lot of students just would rather have the thing to memorize, to be honest. And I'm not opposed to providing that. It is better to just learn it the right way, but I think for a practical matter, like you have a test next week and you need to learn it, I'm not opposed to those tricks. See, it's not it's not a secret. I preach the good word of Paul every opportunity I can, and actually I miss this opportunity. But if I was religious, I would worship Paul. This website is great for everything calculus. So let me give you the narration by parts section here. Because the examples here are, like, I really love the examples that he chooses and how well that they're explained. So I would just look through these. Oh, nice. You know them. Where to get the PDFs from, Najaf? Well, that one is just from Google. Like, I just Googled liate. That's the main one, Art. I don't know of another, like, good one. Okay, so we have that question at the top. Papadoria, hey. I'm trying to take stock of what's in queue. Destin posted yet another problem, which I think is also for fun, so we don't have to do it, but... Sorry, what website is what? Paul? I don't know if you mean a different one. Puik posted a question earlier, though, that I didn't read. Oh my god, Obi! The Half-Life quote. Lamar! Lamar! I love it. Half-Life 2, I think. I hope I'm not missing someone's question, but shout at me if I am. I'm reading Puika's question. There's actually a trick for 3. I think I know what the trick is for the one on top. Like this one. Do I ever do math while high? I never tried to. I would be useless at it. If I have a good high, I am useless to do much of anything. I need to stop slouching too. For positive sequence a sub n with divergent series sigma a sub n, impartial sums going to infinity, yeah, fair. The series a sub n over s sub n to the k diverges for k less than... Whoa. Yeah, Naman, let me know. That'll probably be a quicker one than either of these. Well, I don't know how to solve Pui because question is the issue. I'm sorry, Art. The Discord is just stupid sometimes. It should hopefully work for you in a few days, but I don't know why links break like that sometimes. You have to read some final coming up on an edible? Oh no. It's reading the same paragraph we're giving up and watching the ceiling breathe. That's funny. I didn't know that you mess with weed at all. But yeah, if I have like a nice enjoyable high, I am sitting there and either watching something or just like watching the ceiling breathe. Just the once. Oh, okay, okay. I don't get high very often, like probably once a year or something. It is nice though. I do enjoy it. Oh yeah, fair, fair. It's not like a tradition. That's like on average. I don't usually buy weed for myself, but if someone offers it to me, I'll partake. Yeah, weed. But yeah. Every year on Pi Day. Nothing for the mouse. I usually smoke other people's weed, so I'm more of a leech usually. Yeah, Puka, I'm sorry, I have no idea how you would start with this question here. Any tips on fundamental theorem of calculus? Not particularly, just don't get tricked by the chain rule. If you have, d by dx 0 to x squared, just like t dt or whatever. Remember, you have to do the chain rule on x squared. That's the only, like, trick that I can think of that people will pull on you. But other than that, I think it's... I don't know what else I would say about it. So yeah, I'm sorry, Pui. I don't know how to do your question. But this other question that Destin posted, I think the trick is you would do... if I remember off the top of my head correctly, you do 1 over this polynomial, and then you do a contour integral around this disk. And that you can count the number of roots that way, because the roots will become poles. With an inverse, I assume trig function and a log? Probably not. Not easily, at least. The problem proves there is no slowest divergent series. Oh, really? Yeah, I mean, if you actually want to discuss it more, I can try and Google something. I don't know where you'd even start with that. it's a little too deep for me. Maybe Sarthak? Like, it does look like a P series, but that's not enough for me to go off of, personally, at least. How do I know so much math? It just looks like I do, honestly. I usually have those thoughts about the people who are in chat. Like, how do they know so much math? Oh, here we go. Something to use for divergence of the harmonic series? Well, so the typical idea I'm aware for that is integration. There's another one where you can like think about powers of 2 and doing a comparison. But I assume you mean integration. And so we would do a contour. So this is a weird thing to have to integrate on. And so I think how we do this is 1, 2. I should space them out more. 1, 2, 1, 2, 1, 2, 1, 2. This is definitely a circle. We have to do some crosscuts here. So these two little crosscuts, we're going to hand wave away and say that they're going to cancel with each other because we're going to take the limit as they get really close. And they're going to become almost the same path, but opposing directions, so they cancel. And so what we're going to be left with is integrating clockwise around the inner circle and counterclockwise around the outer circle. Papador is responding to Puik in the YouTube chat. I asked the same question on Zaxxam a couple days ago, as in subtracting any epsilon-like factor would converge, or anything else diverge. So a series of this kind, I just want to know if it existed. It's like it doesn't. The everything series will be ln of n times ln of n times ln. That's a funny idea. Sorry, Damon, I missed the first part of what you said. But yeah, feel free to ask your question, Naman. And happy to talk about it. We get a minus sign here because of the orientation of C1. and that's a good thing. How do we actually do this integral, though? Seems like a problem, right? Is there a trick? Because it's p prime over p? Hey, Chill. Thanks for being here. Oh. Now I'm saying that big recursive element thing does still diverge. So you increasingly pack more LNs, the number of terms you need to increase them by one grows crazy fast. I can imagine, yeah. So it's just, I think the trick for this is that it's ln of p. Yeah. Oh, no absolute value. We're in complex land. Uh... Is this what we're doing? Oh, 2e to the 2i pi. Hey, it's Zach. Well, twice of Zach. This is just one of Zach. I think so. I think we just evaluate the endpoints. I'm kind of... I don't know. Art, I have a bachelor's in applied math, minor computer science, and I'm about to start on a master's in applied math. Let's just see what pops out of this. I don't know. Why was that held for review? What the hell? You hate math? Oh, fair enough. 16e to the 8i pi minus 12e to the 2i pi plus 3. Oh, okay, no. Minus 1 over 2 pi I ln 3 minus... I'm writing 2 pi I here, but I'm writing 2 pi I here, but 2 I pi up here. That's... It really bugs me what order you... Or like, where do you put the I in complex numbers? Like, it really bugs me that I feel like I'm not consistent with it, and I feel like most people aren't consistent with it. You sent everything? Okay. E to the ai pi minus 6e to the 2i pi plus 3 minus ln 3. My binomial coefficient flag. Oh, NCR! Yes. The NCR flag is back up. Hey, crazy. Yeah, you should be asleep. Oh, okay, never mind. I see you posted a bunch of stuff. Like there? And then Slim is asking Art if they're sure they hate math, or maybe just math is intimidating. Yeah, it's a neat thing. I want to give you motivation to sleep. That's what you need. Go to bed. Not you, Mouse. Sorry, that's with one singularity? Alright, see you, crazy. That's for... It counts the number of singularities. Apparently. Numbers first, then other real constants, then I, then variables. That seems like the most common thing, Territar. I just find myself even switching it up. So yeah, no mind, I'll look through your stuff right after I hopefully wrap this up. Hopefully. If I don't make progress soon, I'll just switch. What's up with this? One? No, 0. No, 1? 1. Don't Google what that is. I need to know what you're putting in my chat, though. Oh, okay, that's nothing bad. One minus 6 plus 3. Well, that's a negative number. That's okay, because we're in complex land. 1 minus 6 is minus 5 plus 3. Why can't I do math? Negative 2? Oh. I didn't save that mouse. If you mean the one from like yesterday or 2 days ago. Yeah, it's true. I don't know if I'm getting a number that's reasonable though. Like what the hell is this? Are these two supposed to cancel, but they aren't? Is that what's happening here? Indefinite integrals don't have a or b. Indefinite integrals look like f of x plus a constant. Definite integrals are solved like that, though, Art. I think I made a mistake somewhere because this answer looks a little bit nonsense right now. I think I have the right trick, just not the right application. I remember the idea is that you use, like, this setup is so you get a logarithm, and the branch cuts of the logarithm is what counts the number of poles. That's the idea behind this formula. I don't know why I'm not getting the right answer out of this, but I might not have been careful enough with, like, this algebra here and how the branch cuts might affect the log. I don't know. Let me look through what Naman posted, because I don't want to spend too long on one problem here. Riemann sum. If it's piecewise, the same thing still applies. Yeah, integrals actually play pretty nicely with piecewise functions like that. Those are just... Oh, okay, okay, okay. When do you learn that? That's usually in your regular calculus class on integration. That's a good question, Territar. From the phrasing of this, it sounds like no. Or like it won't count them properly. Like it would count a pole of order 2 only once from the sound of the phrasing. I don't actually know, though. Oh my god. Wait, this trick might not even hold. I assume the roots are distinct when I use this trick. We don't know if the roots are distinct, though. So that's another issue with my solution there. Art, if a link that doesn't work for you, just try it again in a few days. I don't know why Discord does that. It's really annoying. It should hopefully work for you eventually. Yeah, Papadoria, I know how to do that. You usually draw a right triangle, and I can show how it's done. So if you're just going hard on the Riemann sum thing. Rouche's theorem? Or, I think it's Rouche. I've heard of that. I don't remember what it means, though. Or, Oh, yeah, that could be helpful too. That's a probably more robust way of doing this. Because you don't need them to be distinct here. Yeah, it's a good call, Mouse. You have to be creative, which is annoying. Like, you have to name an f of z that works here, but yeah. That's a better idea. A Riemann sum? Yeah, that's like the definition of an integral. Uh... If you want to bound it from below, you would do a left hand, like... It's like, so there's left and right Riemann sums. And it depends how the function looks, but you would just do the other Riemann sum. Oh, alright, Papadoria. Sorry about that. So that's to do with how you construct the sum. We can talk about that in a minute. If you're doing it with like x squared, so I didn't look closely enough to figure out which one that you did. If you're bounding it from above, yeah, so it looks like you're just making rectangles to approximate the area under the curve. And that's what a Riemann sum is if you go out to infinity. And so you can draw rectangles, let's just say like you want the area from here to here. All right, good night, Mouse. Thanks for hanging out. You can draw rectangles, and let's say we're gonna use 3 rectangles. As a rule, you can draw rectangles either they on the left side they go up to the function and that determines their height, and you'll get rectangles like these. This would be a left-handed sum because these left corners touch the function. Or you can do a right-handed sum. Where the right corners touch the function. What a terrible rectangle. And so, just visually, you can see that this underestimates the area because of these gaps here. And this overestimates the area because of those chunks there. And so, one is your lower bound, one is your upper bound, and you do it both ways. I think midpoint gives you a better estimation, but you're never sure if it's an over or under estimate. So if you want to just, if you're trying to get a strictly lower bound or strictly upper bound, left or right is better. Yeah, and so even then, you need to be careful. Like, the function needs to be strictly increasing or strictly decreasing. Because if you have, like, a sine wave, or at least, if you have, like, a sine wave and you do, like, a left-handed sum, sometimes it'll be under, other times it'll be over. So, like, be careful of that. Like, you should only do a portion of the wave. Like, if you could do that portion if you want. Trapeziums are good too. They converge a lot faster to the true value. Yeah, as Academy of These Ideas says, it's harder to prove things with midpoint. I think trapeziums are always an underestimate. They are like a little harder, but I don't think they're that much harder. Because it's just like the area of a trapezium, you know what these 2 points on the function are? So that's like the thing you'll take the average of. It'll be like f of x1 plus f of x2 over 2, and then the width is your delta x. So it's not that that much harder. You just have 2 points to deal with instead of 1 now. But you're right, it is a little harder than rectangles. Okay, so Art asked a question about an integral. Yeah. I don't know if I've done this integral myself. We can mess with it, though. Art wants to integrate ln of x squared dx. So, if you only have one function integration by parts, I don't know if this is going to work. But the trick that you can use is remember that there's an invisible 1 here, and you can integrate that 1. So I would say u is ln. Like, if integration by parts does work, it'll be like this. Well, not necessarily. There's another thing we can do with integration by parts. Can you take the formula at the end of the second page, second last page as reference? I don't know what you mean by that, Naman. Like that one there? The one above it. This right here? Yeah, I think it's just the regular formula for a Riemann sum. If you let n go to infinity. That looks about right. Not the page. Oh, this one here? So what are you doing with this? Or like, what are you asking me to look at with that? Plugging in increasing values of n? Yeah, if you want to verify the result of the limit, you could do that. Your result there is right, but yeah, like you just like take a value for a and then start plugging in n's. And you can estimate the limit that way if you really want to. So the derivative of this is 2 ln x chain rule times 1 over x. V is equal to x. So uv v du x ln x squared. Oh wait, this is good. 2 ln x times 1 over x times x. Yeah, this is good. Because we get x ln x squared minus 2 integral of just ln of x, which is fantastic. So we can use the same trick again. With remembering that there's an invisible 1 here. I just know what this integral is, but I'll show you how you do it. It's going to be x ln x minus x. But we do it using the same integration by parts trick. U is ln x, dv is dx, du is 1 over x dx, v is x, uv minus v du. Minus 2, remember the parentheses here. X ln x minus integral of x times 1 over x dx. Fantastic, because that's just 1. I didn't know that going into it. I just got stuck with the integral of ln x. And so that just needs another integration by parts. Like, you have to see what you get for that integral and then figure that out as a new problem. And that problem happens to need integration by parts again. So I'd say this is the answer here. No worries. Rouche's is very powerful. I tried to read the proof once and didn't understand the idea. It's used to prove inverse function theorem. Oh, nice. Fembox is being fired. Instead of being paid, you were accumulating debt. Yeah. The article thing just clicked. Oh, good, good. So yeah, we can think more about that Rouche problem. Like, you just need to name an f of x that bounds it from above. That's simpler. Oh, good, good, Naman. No worries. So this is like almost the same problem here. Aw, that's nice, Mouse. What do you do if D is not given? You have to find the region where the most zeros are found. That seems like a much harder problem. I feel like you're gonna do some type. You're gonna end up doing by hand some type of numerical algorithm. Like you'd have to start by guessing a D, and seeing how it works out. I don't know of another way to do that. Yeah, Naman, that's a theme throughout calculus. It's a really cool one. Where you start with an approximation and you make it exact. Oh, this is called complex analysis. It's you would take a class like this a good bit after taking a couple of classes in calculus. It's fairly advanced undergrad, I would call it. It talks about how complex numbers can help solve calculus problems, basically. Uh, and so it's all about throwing complex numbers into calculus and doing helpful things there, basically. And so it can help out a lot, especially with integrals to infinity. Not necessarily to infinity, but often with infinity. Oh, I'm not sure I'm making a true statement here. I don't think I've seen a meromorphic function picture. What would that... Is there a nice visualization? What, like this? Yeah, it's like gamma, but you get neat visuals, I guess. I don't know. What's up, mouse? Yeah, I'm realizing that this isn't an act like I'm not gonna meet that part. That might be a better bound. Yeah, mouse. Or a better choice. Oh, really? Naman? That's funny. I mean, in a way it sort of is. Like, if you have a function that, like... You can have functions asymptotically approach a number. Like, if you have, like, inverse tangent here, it'll approach pi over 2 up here, but never actually equal pi over 2. So, like, in that sense, you could kind of call that an approximation. But, yeah, I don't... they might mean something else. The limit is exact, yeah. The actual function is never that, though, I guess. Yeah, it doesn't. I think you definitely want to use the parts of the function. That's going to be the most clear way to use Rouche's, I think. I want to say it's true that f of z is greater than g of z. It feels right. I don't know how you really show it. Do you mean like what does rule of thumb mean? It just means like a rule that you kind of like often use. Yeah, I'm trying to think about like values close to 0 also, but it should still check out there. Descent means like when choosing f and g, use parts of the function. Don't invent your own f and g. Like, just choose pieces. Hibbed. Okay, so that's a good question. Complex numbers are just a new type of number. You probably at this point in math you've learned about like whole numbers, which are like 1, 2. Let me like type this. You might have learned about whole numbers, 1, 2, 3, and so on. Maybe integers, -2, -1, 0, 1, 2, so on. Rationals that include like fractions. Complex numbers are their own thing. And so when we make the x and y axes, we normally mean that with real numbers, which I didn't describe. Pi, 1, -2 point whatever. Our x and y axes are normally talking about real numbers specifically. It's just a way of representing like pairs of real numbers. Visually. Oops. Oh no. We can also represent them one-dimensionally on a number line. So like at some point you probably have done them like 0, 1, -1, 2. I can say that the real number 1 is right the hell here on the number line. Pi is somewhere over here. When we do complex numbers, if we want to represent those, it's basically our good old number line, but evolved. Like, we need an extra dimension now, because there's a real part and an imaginary part. So now, like, the number 3 plus 2i is over here now. We have a real number line and an imaginary number line. And so this is a really different thing from x and y axes. Because with x and y axes, x is your input and y is some output. Like, in terms of, like, functions. But here, the real number is just a number. Imaginary number is just a number. There's no input, output. There's no functions happening here. So that's where the confusion, I imagine, probably is. If you want to show functions with complex numbers, it's much harder. Because you have, like, an imaginary number going in and a different imaginary number going out. So it's like you have a 4-dimensional problem. Because these are inherently two-dimensional each. And I'm sorry, that part might be a little bit confusing. But that's basically why, because complex numbers have the two parts. You want to say no? Oh, great. I'm glad. I wasn't sure if I was talking in circles or not. But yeah, they happen to look a lot like x and y coordinates, but it's a different idea. It's way more like a number line than it is like x and y axes. Naman was saying instantaneous velocity, right? Yeah, that's fair. Naman. The X is for quaternion? We just have 4 axes then, right? Rouche's is too powerful, destroyed the exercise? Did you... Oh, was there a different way that we were supposed to solve this, Dessen? Pui is saying 6z minus 3 is greater than or equal to 6z minus 3. I guess that's triangle inequality. Or something. Three roots? Because of D. I don't know how you just find that. Then why some delta distance has to be satisfied in Rouche's theorem? Me neither. Well, I know that D is the annulus. I don't know why that's helpful here. For saying that it's 3 roots. Okay, yeah, I'm sorry. I have no clue what either of you are saying. If you figure the problem, I want to just move on. But I'm not following either of your trains of thoughts here. Yeah, minus 6c has a root. So at most, there's 3 roots between 1 and 2. But you still need to show... Well, no, you have to worry about roots outside of 2, though. Like, you have to prove there aren't roots outside of 2. Or do Rouche's a second time. Well, the polynomial is defined for all complex numbers. We're asking about the roots in that annulus. Yeah, and they do Rouche's multiple times. They name an they first do Rouche's for the inner contour, and then they do Rouche's for the outer contour. Hey BR, I'm doing well. How about you? We've only done it once, like that's not enough. Yeah. And so I'm like I'm starting to care less and less about actually doing it, but I know what you would do, which is just find a new f of z and g of z. And so you're saying it'd be z to the 4th for f? All right, I'm just gonna believe you because I don't feel like doing it. I don't think I don't know how. Yeah, no worries, Dessen. Oh wait, so were you actually asking like for help with these? I thought these were just like for fun. I was gonna just skip over this one, assuming it's also for fun. But if you're actually asking, I can try to do something with it still. You have to pass an exam. You don't have to call me out like that. I am, but you don't know that. Alright, good night, mouse. I make you love math too much. Oh wait, is there... Do we just go to sine over cosine? Oh, with summer math exposition? Yeah, the submission's closed. At my time, 5 a.m. this morning. Or the voting closed. So in a few weeks they'll announce who the winner is. Said America were not fake nice. I mean, I think Americans are just friendly. I don't think it's usually fake. Sometimes it's fake. So aside from the, well, I guess we don't have any discontinuities here because of the AI. Okay, so maybe I see what Ivan was saying, where the A not equal to 0 means there's no discontinuities. Oh, I didn't... Really? I need to watch Slims then, because I don't think I saw it. Is that seriously the integral of tangent? That doesn't feel right. That feels too simple. Don versus Slim karaoke? Okay, I guess I'm right. I feel like I'm doing something wrong. You know, Justin, I don't have to be doing this at all. All right, then shut the fuck up. Like... Oh my god. This is some version of cinch here. Kosh, same thing. Cosine of pi plus something is surely the same thing as cosine of something. Or like negative cosine. Oh wait, I mean, is this gonna hold true if it's an imaginary number though? I don't know. I'm just gonna do it. It's just Kosh. Well, the negative sign is kind of concerning. Kosh is always positive, isn't it? I mean, I guess it's complex numbers. What is, like, does ln of Kosh simplify, though? I don't think it does. It looks nearly like a y equals x. Oh my god. True. See, now, unironically, a genius. And not just making fun of me as I'm trying to help you. Minus I pi, I guess? The A goes away? Huh. I wonder if Wolfram Alpha can do this. Uh, there is a minus I pi in the top part here. E to the real part of A less than 1? I don't quite know what they mean with that. Oh, they're assuming A is complex. I guess. Yeah, I'm wondering if something was even... Like, I guess it seems to get the right answer. I wonder if something was invalid. Yeah, that's a good idea, Fembox. Wait, positive IPi. Oh, wait, that's stupid of me. I'm no longer a genius. This negative sign went away, but I accidentally carried it over. Suna, hey! Well, I was about to ask you. It's going well for me, though. How about you? Okay, yeah, I guess it's IPi. That's weird. Yeah, Destin's been asking some like complex analysis questions. This one, it's weird. We hardly use any complex analysis theorems to solve it. So it feels a little bit odd. We don't have to work harder. A is 1/2. Let's try it. Nice, nice. I pi. Yeah. Yeah, we try a negative. It's a good idea. That gets a negative there. So we have to worry about the sign of A in one of these steps. Which step would that have been in? Oh, I would want to see your solution, but if you gotta go, you gotta go. Ready for grad? I'm being forged in the fires of Destin questions right now, so hopefully I am. Oh, you know what? I bet the issue... No, is it? I wonder if the issue with the sign of A is right here when I make this step. Maybe not. There you go, Destin. I don't know. So there's a slight error here with the sign of A. I don't know which step it was in. But I'm calling that good enough for me at least. It's so weird. I don't know. No. I wish I did, because that means I would be funded. Um, I when I was accepted to the program, they did not offer me funding though. So that also means I don't have to do TA work. I applied to be a TA at other departments, at the math department and at the computer science department. Uh, Neither of them accepted me though, because they give priority to their students first. So I'm just not planning to have a job, but if the workload isn't that bad, I might look for one, even if it doesn't come with funding. Yeah, maybe Destin. I don't know. Apparently not, because I got told no, so at least no for now. Yeah, that's possible. Before I ever even accepted the offer of admission, I planned out the finances of just not having funding. So unless I screwed something up, I should be fine either way. It just would be nice to have funding. Having a job that isn't funded isn't nearly as appealing to me. Although I'm not completely opposed to it, just it depends on my time. Um, no, well, okay. I applied to PhD programs if there wasn't an extra cost in doing so. Because a lot of times the application for master's and PhD is the same thing, you just tick a different box. So I did apply to a few places for PhD, including UW. No one accepted me for PhD. As of now, my application is just I just don't have a strong enough application to get to get accepted for a PhD by a typical school that I would want to go to. I am planning to apply to continue on for a PhD here. I'm not planning to apply to other schools right now. Maybe I will, but I don't know. Yeah, it's definitely fierce. So if I actually get a master's, I'd be in a way better position to apply for a PhD. I got good grades in my undergraduate degree, but the courses I chose were very much not proofy and what probably were getting interpreted as avoiding the hard classes. And I think that's a flaw in my application. I also had so I've applied to PhDs before, actually, way before I started streaming. But this round of applying, I got screwed over by a professor who promised to write me a letter of recommendation and then never followed through. And so I had to scramble to get a letter of recommendation from just like my old boss. Just so I could at least meet the requirement for 3 letters. So that also wasn't helping me. Got horrible grades for non-math courses, C in topology, everything else is A. Oh, fair. Always contact 3+ professors. I mean, yeah, I guess I should have. For me, it had already been like 6 years since I graduated, and there's only one who ever kept in contact with. So it was already hard to even get those 3. But yeah, it would have been safer to try to ask more. It's not a very long list of people who I could even ask in the first place, though. Najaf, oh god, good luck. Professor passed away, is going to write a recommendation. This is a beginning in algebraic geometry. Aw, that sucks. Only in his 70s? Damn. It's not that old. Okay, so the part here that sucks, that I got stuck on, is trying to invert the Fourier transform here. That's a good old Schrodinger equation, which I still don't get the fuss about. I mean, I have no clue what it means. I just want to solve this PD. But this is where I got stuck the last time, which is this integral sucks balls. And so obviously we don't know what f hat k is, but we can use convolution. Yeah, Catmaster. So we're given that initial condition, and so I found C of k to be f hat k. Waffle, how's it going? It was good to see you reviewing videos. No worries. That entire review-a-thon was a lot of fun. So we have the product of two Laplace transform or Fourier transforms here, and so we don't know what f hat is, but we can use convolution. We just need to figure out the inverse Fourier transform of e to the minus I k squared t. It's just that part is terrible. Because we get this stupid integral. Imagine a factorial walrus. It's walrus times walrus minus 1 times walrus minus 2. Is it, Catmaster? Like, this integral is just painful. I wasn't able to figure it out. Yeah, that's what I was doing, but then the leading coefficient made doing a U sub seemingly not possible. Let me get to the actual place where I was. Hey, famished. How do you integrate a lemur? It's very true. Mathematicians have not answered that important question. Yeah, it is back up. So I'm gonna factor out the minus IT. How's the the new place. It's good. It's a little bit hot, but that should be fine once winter gets here. It had a whole bunch of issues when I first moved in. Like, I basically had to get all the appliances replaced, which the landlord was on top of, thankfully. But now that I'm settled in, it's pretty nice. Thanks for asking. Bob, holy crap. I'm solving Schrodinger's equation with Fourier transforms. I guess I'm trying to. Moving's basically a full-time job. It really is. Grad friends on stream in the future? That'd be cool, Desson. I'm not good at making friends, though, to be honest. If I meet people who I think might be willing to, I think that would be fun, though. So yeah, I was doing this problem off stream a day or two ago, and I ended up with this integral that should be possible, but I just could not, like, a U-sub just wasn't. It's like they give a hint that you're gonna get this like Gaussian integral, but I just could not quite get it in that form, no matter what I did. Oh no! Okay. Thank God for undo. Okay. Okay, so I completed the square. The issue is the t and the negative sign. I don't know how you deal with those. That's the only thing that's stopping me from progressing in this problem. Because otherwise I would just use this fact here and be good. I can grab the song. Days of Thunder by your friend, The Midnight. Oh, so this place is about to run out. Wait, what time is it? Okay. Oh, shoot. I have plans. I can't stream for much longer, actually. Every song is a winner? Yeah. It does sound a little bit samey with the saxophone every time, but it's not bad. Really? Minus T. I was thinking about that, but for a second I thought it wouldn't work. So now we're bringing it inside here. I didn't like that it's creating another imaginary number in there. But like, I guess? Question mark? A nice QM interpretation. Should get a solution for the heat equation with T replaced by I times T. That's why people sometimes call Schrodinger equation the imaginary. Really? Huh. Oh yeah, it is basically wait, the heat equation is second derivative on time, right? Now it's the song, yeah. Alright, let's just see, like... So if we do the U sub, we're gonna get a factor of negative root t, or root negative t. The rest of it becomes e to the I pi over 4 root pi. Oh, you might be right, Catmaster. Sorry, I might have them backwards. Or I might have the second derivative in the wrong spot. First derivative of time. Oh, okay. Yeah, never mind. I'm just crazy. I thought it was switch. I thought the second derivative of time is the first derivative of space. So then from the U sub, we get times that. And then the result of the integral. E to the I pi over 4 root pi. Huh. So definitely numbers. Can tell you that much. Question mark? This isn't the end of the problem even. But just taking a look at what I've written here. I guess. Um... I need to see how long it takes me to get to this place. Okay. Yeah, I want to close this problem out because this is just all this was so we could do the convolution. Okay, let's at least write that piece out. So u of x t is the convolution of our initial condition, f of x, and this stupid thing right here. Okay, nice. dx. Oh, no, 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 no. Wait. What are we convoluting in terms of? I guess an x? I need x primes. So I took the Fourier transform in x, right? So my convolution should be with x. You need to live authentically and you can't ignore that. You know, that's not a bad fortune, I guess. It's a little weird. Yeah, it is big. You can watch math on Twitch and know what's going on. I wish I knew what was going on. And so this is the part where we would bring in the Dirac delta function to get the Green's function. The best mirror is an old friend. Yeah, you know what? I think I like that. Like, really? I think if you want like an honest look at yourself, like an old friend is the best, like the closest thing that you can get, I think. It's more poetic though? Yeah. Um, I I don't know. I'm both tired and I need to go. I think I don't like leaving this problem unsolved, but it's gonna take a little bit too long to solve this. Schrodinger's equation work. Save. Hi, both tired. I need to go. I'm waffle. Oh my god. Feels like physics random functions are pulled out from the magic hat. Yeah, the way this book is doing it feels very random. I don't know. Yeah, it is very sunny. Yesterday was randomly super hot. Like, it got up to like 86 or 90 or something. Today it's like only 75. I want it to be cold. I know, this is what math does to me. I just glow. Alright, YouTube stream's getting cut off here. Basically find the analogy of the heat equation super helpful. Yeah, I'll have to look that up, Catmaster. Thank you very much for helping me out with that. So I did not feel like that was a legit step, but